Okay. So hi everyone, you can hear me, right? Okay. Let's start. So just to recap, one final thing is that what we are doing, basically, given any determinant, how we are finding the determinant. Let's suppose it is A1, 2, or maybe A, B, C, D, something like that. Let me write A, B, C, D only. Let's say this is A, B, C, maybe this is X, Y, Z, P, Q, R. So how we are finding the determinant? We are taking one of the element from, like, there will be six terms, and how we are finding, we are taking one of the element from here, a one of the element from now see, I cannot take from here because that won't survive anyway, right? So I'm taking one of the element from, maybe let's take Z, and then I will take Q. So this is just one possibility, A, Z, Q. Okay, so A, Z, Q was just one possibility. So what I said is that I will take one of the element from A, and then once I take A, maybe let me take one of the element from the remaining possibilities, that is Z, and then sorry, that is Z, and then I will take the remaining element, which is Q. So AZQ will survive definitely. Plus, sorry, this AZQ, the sign will be plus or minus, that will also matter. So I think it will be AZQ will be minus, right? And then maybe you can take other things. So minus AZQ will be one term here, and then maybe you can take this A, and there were two possibilities at this row. Then instead of taking Z, let me take Y this time. If you take Y, then this will be A, Y, and then only one possibility is left, R, right? So there is another term which is this, and then maybe if you take B in this row, and then for corresponding to B also there will be two terms. If you take B in this row, then can you tell me two terms? If you take B, then I think the two terms is, uh, maybe you can take X here, and if you take X here, then only the possibility left is R. So if you take X, then the only possibility is R, and it will be plus or minus. I think, can you quickly tell me BXR is plus or minus? Anyone? Minus, right? Okay, this is minus. And then maybe if you corresponding to B, there were two options actually, the X and Z. I have taken X, let me take Z also, maybe plus B, Z. And then once you take Z, this column is done. I think P is only possibility. And then in the last column, if you take C, then there were two possibilities, X and Y. Let me take X, and then let me take Y. In this case, if you take X, let's just focus on the X. CX is done, only Q is left, and C by is done, then only P is left. Okay, so CXQ, I think, can you tell me what should be the symbol? C by P. C by, okay, let's first focus on CXQ. CXQ, what should be the symbol here? I think you can, this is 3, 3, 1, 2, and to get 1, 2, 3, maybe you can just swap these two and then these two. You need to swap two times actually, right? 1, 3, 2, and then 1, 2, 3. So that's why this is plus. And then for by C by Q, C by P, C by P is 3, 2, 1. 3, 2, 1. I think for that you just need one swap, maybe 1 and 3. So that's why it is minus. So ultimately this will minus. So there are 6 terms that will survive. Other than that, nothing will survive. So finally the answer is having 6 terms. Arpon is saying BXR is plus. Okay. BXR is 2, 1, 3. To get 1, 2, 3, I think to get 1, 2, 3, you can just have one swap, 1 and 2, right? One swap. So 1, 2, 3, just one swap. So that is why it is minus. Okay. Okay. I hope that is fine to everyone. Now let's solve this question probably. Sorry. Where is that question? Yeah. So now let's solve this question. And I want to solve for this determinant. I will do the same thing. I will be picking the elements and I will say that, okay, which one will survive. So here I can pick this, I can pick this, I can pick this, I can pick this. So there are 4 possibilities, but obviously these 2 possibilities are useless. If I pick this, then it will not even survive. So let's not pick these 2. Let's pick this. Then 1 into, what else I need? 1 into, in this second row, what can I pick? Can you tell me in the second row, only the term that will survive, that is useful to me, only I think one, right? I mean, you can pick this zero, you can pick this one, you can pick this zero, but only one is useful for me, right? So if you're picking this one, then this one from this row is final. Okay, and then this particular row you need to take, I think there are only two possibilities, but obviously this zero is useless, so I will take this one and then this one. Yeah, so this is 4 times 1 and then 1, and then finally this is basically 3 2 1 4 3 2 1 4. Can you get 1 2 3 4? I think maybe this will be one step. 3 2 1 2 4. Okay, maybe let me swap 1 and 3. Okay. हाँ मतलब you can do anyway, doesn't matter. Let me say 1 3, maybe 1 yeah, I think this is fine, right? 1 and 3, if you say 1 and 3, then it will be 1. So it will be one step, so that's why it is minus. So if you're taking 1, then fortunately we just got one possibilities out of this one, but there could be multiple possibilities also. We have to explore the possibilities. So you take this, okay, that one survived. You take this, that one survived. You took this one, and out of one there is only one possibility, which is -1. Then you just take this one, and that is the last combination that you're remaining with. So basically -1 is there by taking this one. Maybe by taking this one, you will say -1 is there. Okay, by taking this one, and -1 is already there, and then let's just take this one. If you take this one, then I think in this, okay, there are two possibilities. Let me take one of them this time. Let's take this. Okay, if you take this, then yeah, this you have to take, otherwise there is no option. Okay, I mean, these two are out here. Okay, you can take either this. See, if you're taking this, then you can take this or this. There are two possibilities. Let me just go with one of them. Maybe you can take this. And then here also there are two possibilities. But if you go with this possibility, then you are left with 0. So this is not a good possibility. So this is only possibility, right? I mean, this is one of the possibility. I think this is 4 3 2 1. If you want 1 2 3 4, then you need two steps, right? Two steps you need. So that is why this is +1. Okay, and instead of this one, if you choose this one, don't worry, like we will be solving with the formula. I'm just trying some combinations. So if you choose this one, then I think these two columns are done, and then you can take this one, and then you have to take this 0. Okay, so answer is 0, right? Answer is 0. If you take this one, then you have to take this one. There is no possibility, and then this is 0, right? Okay, so +0 I can write. So basically, I mean, there were two possibilities. Either you take this one. If you take this one, then I think we are getting the 0 only. So one minus 1, final answer is 0. Okay. So anyway, my motive is not to solve questions using that formula, but my motive is to drive the formula finally. We will be solving the questions using just a general row reduction, which means we will be maybe swapping the rows or columns, and then we will be applying row formulas, which is Ri gives Ri plus Krj, something like that. Okay, we can apply this. Can we apply this? Just tell me. Can we apply this? R2 gives maybe 2R2 plus R1, something like this. Can we apply this to find the determinant? No. I mean, if we apply this, then determinant is getting multiplied by 2 actually. Okay, then final answer that we are getting, okay, it is already multiplied by 2. That's why we need to divide by 2 with the final answer. I mean, if you are doing this, that's fine, but ultimately you need to divide at the end. Okay, so these kind of things you need to take care. Otherwise, I will suggest you to just focus on one elementary operation, which is this. If this is Ri, just take Ri here also. I mean, in whenever you are solving for Ax equal to b and these kind of things, then this is okay. I mean, for that thing, you are multiplying equation by 2, you are adding two equations, these kind of things are okay. But here, if you are using some row operation, then just use the elementary row operation. Elementary row operation means Ri gives Ri plus Krj only. There you do not have any multiple here. So this is elementary row operation. Elementary Okay. So elementary row operation means like you do not have any multiple. If you want to have multiple, you can have, but ultimately you need to divide by 2, because whatever you're getting is basically 2 times of the final answer that you should be getting. Okay. So I will say if you're confused, then just stick to the elementary row operations. No, there is just a row operation. This is not elementary row operation. Okay. Elementary row operations are just three. Three, can anyone tell me? One is, I think we can swap RIRJ. Another is this. Ri gives Ri plus KRJ. Another is Ri can be replaced by KRI, but here also you are getting the multiple of K. I mean, this will not change anything, no change in determinant. This will do what? This will change in sign. This will do what? This will multiply. Okay. 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 Now let's move to our main formula. I mean, which is the cofactor formula. Using that, generally we find the determinant. Okay, so these are the few properties of determinant. Like we are not going to prove every property because that's not required. Like I will just give you the formula. So basically, determinants can be evaluated across any row or any column. I think that will make sense after the cofactor. Okay, let me first probably move to the cofactor formulas. Okay, this is one question. If you want, you can solve it. Maybe you can solve it as a homework. Okay, this is not a tough question, very easy question. Let me move to the cofactor formula. Okay. So calculating determinant using the pivot or the cofactor. Basically, if you can make a matrix as a diagonal matrix, then also it is fine using the row operations. Then finally answer will be just a multiple of the pivots. If you do not want to make, then you can use the cofactors. So basically, there will be generally there are only two ways. Either you can make a matrix diagonal, or you can directly use the cofactor. But for the theoretical explanation, I will say there are three ways to calculate the determinant. One is using permutation. Another one is using, convert given matrix to echelon form, or let me call it triangular matrix, and take product of pivots. This is also one way. Another way is you can basically calculate the cofactors that I will tell you just in a while. So another way is you can calculate using cofactors. Okay. Mostly we will be using either this or this. Okay. Let's go to the second type of things, which means we will be calculating the determinant either using pivot or using the cofactors. I think the first thing is quite clear to everyone, that how to convert into echelon form. Once you have the echelon form ready, then you can just take the product of the pivot element. Okay. So suppose this matrix is given, and I want to calculate this matrix determinant. And it so happens that this matrix determinant is 5. Can you do this using the pivots? If not using the cofactors, can you do this using the pivots? I think we can do it. Maybe you can make maybe this 0, this 0, and this 0. These three, can you make it 0? So let's just try doing it. If you make this 0, 2, I think you can replace this R2 by R2. Okay, let me not have any general row formula. Let me just have only elementary formula. So you can replace R2 by R2 plus maybe 1 by 2 R1. Is this okay to everyone? If we replace R2 by 1, I think it should be fine, right? So it will be finally it will be 2 minus 1, 2 minus 1, 0, 0, and then it will be if you do 1 by 2 r1, then 1 by 2 r1, and then it will be 0, 1 by 2 minus 1 by 2, and then if you add it 2 minus 1 by 2, which is 3 by 2, 3 by 2, and then minus 1, and then this is just 0, and then this is 0 minus 1, 2 minus 1, and then this is 0, 0 minus 1, 2. Okay, let's just use this also. Let's just convert this to also 0. So generally, like I mean, in general, this could be anything, this number could be anything. So what we do basically, if you want to replace r3, then r3 plus, basically you will divide this r2 by whatever. Let's suppose this is a, then 1 upon a r2, which means you will first divide that by itself to make it 1 here, and then you will have a opposite sign of this. So whatever is the sign of this, which is b, let's suppose if this is b, then in general you can say it will be, like in general it should be, I think, minus b by a, right? If a is here, if b is here, then if you divide by a, then it will be 1, and then if you multiply by b, then it will be minus b. I want minus b here. So in general, this is the thing that we can apply. Okay, so here you will be replacing this r3 by r3 minus b is basically minus 1, so it will be 1 upon a. A is 3 by 2, which is 2 by 3 r2. Okay. Okay, so if you do it, can anyone do it? Or you can do it as an homework. I think it is just a calculation. Just try doing it. Okay. Or if you're not comfortable with the fractions, then you can multiply by 2. That's okay. But keep that thing in your mind subconsciously that you have multiplied by 2, so that at the end you divide by 2. Okay. You're getting my point? So if you want, you can keep, you can multiply by 2. That is okay. That is not a problem. But keep that thing in your mind that, okay, you have multiplied by 2, so that finally you divide by 2 also. Okay. So you just do it at your home, and then finally you can find the determinant, which should be 5. Okay. So pivot formula says that after converting A to upper triangular matrix, upper triangle means echelon form. The pivots are, let's suppose this, are on the diagonal. If no row exchange, see, whenever you're converting to the echelon form, then there could be the row exchanges. Then if no row exchange, then the final answer is just a product of pivots. In general, if there are row exchanges, depending on how many row exchanges are you doing, depending on that will be plus and minus. Can anyone tell me why we do row exchange? While we are converting to the echelon form, why we need to do row exchange? Because there are some zeros on the way. Okay. Yeah, so if there are some zeros on the way, so to make this as a pivot cannot be 0. So we just do a row action so that it is a non-zero. I hope you remember. Okay. Now you can convert this to a echelon form, and then you can find the determinant. Maybe like this is the example. Maybe you first need to swap these two rows. Maybe you have 4, 5, 6. And then let's suppose this is 0, 2, 3 and 0, 0, 1. So remember that final answer should be multiplied. Let me say multiplied, or divide does not matter actually in case of -1. But okay, let me. I mean, multiplied actually does not matter in case of -1. So you just remember that final answer should be basically multiplied by -1. Okay, and then take it. Then let's just, okay, this is already 0. Let's just, okay, this is already 0. So this is -8. I think -8 should be the answer, because final answer should be multiplied by -1. It is 8, but it is -8 because of final answer should be multiplied by -1. That's what I have already written, because that's a row swap. Okay. Okay. I hope that is fine. Now let's go to the cofactor formula, which is general formula, and most of the time we will be using this only to find the determinant. The determinant is the dot product of any row I of A with its cofactor. So there is a cofactor matrix using the other rows. Cofactors. Okay. So basically there will be a cofactors. Let me just tell you that how to calculate the cofactors, and the determinant will be just A11 into the C11, which is a cofactor, and then plus A12 into the cofactor of this. So this will be the final determinant. Okay. Let me just tell you that how to get these cofactors and all. So how many terms are there in the cofactor expression? Can you tell me? So there are n terms. One term is this, another, third, like that. There are n terms. and this is one of the cofactor. So I will say that Cij is cofactor. What is cofactor? I will tell you. Okay, is a cofactor of Aij. Cij is a cofactor of Aij. We calculate the cofactor and then we do this. Then we finally get the determinant. Okay. Now, how to calculate this cofactor? Let's just talk about it. Okay. So what we do, let's suppose I want to calculate the cofactor of this 2. Then what I will do, I will take this 2. I will just hide all of this, maybe this first row and the first column, the corresponding row, corresponding column, and then I will take this as a determinant. Okay. So I will say that this thing, which is 0, 4, 5, minus 7, this thing is a cofactor of 2. This thing I call it is a cofactor of 2. Okay. Basically, it is also based on the sign. If that is the first element, then the sign is plus. Like you must be knowing it. It goes like this: plus minus like this, right? So if this is 3 cross 3, then it will be just plus, and then plus minus plus. I will tell you the derivations and all, but for now just focus here, because we first need to learn that how to calculate the cofactors using the given determinant. So this is plus minus plus minus plus minus and then plus minus plus, which means that initially the sign of cofactor is plus, and then if you calculate the cofactor of minus 3, then cofactor of minus 3 will be, let me write, cofactor of minus 3, it will be determinant of 6, 4, 1, minus 7, but with the minus sign. Okay, cofactor has a sign in it, which means if I'm asking about the cofactor of 2, it will be plus sign because of this. If I'm asking cofactor of minus 3, it will be minus sign like this. A cofactor of 5 will be having the again plus sign. Okay, in general, sign of Aij, sign of cofactor of Aij, I cannot say sign of cofactor. I mean, because cofactor itself is a sign. I mean, I don't know what should I call it, but yeah, you are getting it right. So sign of cofactor of Aij will be minus 1 power I plus j, which means if I plus j is even, then sign is plus. Otherwise, the sign is minus. So if you want to calculate this determinant, then what you will do? You will just calculate the cofactors of 2, cofactor of minus 3, and cofactor of 5. So this is cofactor of 2, which is basically this. So you will be writing 2 into its cofactor. So its cofactor is 0, 4, 5, minus 7, minus 3 into its cofactor. Its cofactor is 6, 4, 1, minus 7, but that is with minus sign. So that is why it will be plus. And then plus 5 into its cofactor. So its cofactor is 6, 0, 1, 5. Okay, you can calculate this, and then again, like you can calculate the cofactors of 0, that will be useless. Then cofactor of 4 will be 5, but minus 5. So it will be 2 into 4 into minus 5. Okay, plus 3 into, you can actually calculate it. This is minus 42 minus 4 plus 5 into 30. Can anyone tell me the answer? What is the final answer here? Okay, let's calculate it later. You can calculate it. Okay, so whatever is the final answer, you can get it. Let me move to the next slide. So now they're saying that write down the determinant of A, that's what we have just seen, along with the expansion of second row. Basically, you can expand the determinant based on the first row, based on the second row, based on the any row. So if that is given to you, then in this determinant, can you write based on the second row? Okay, let's just try doing it. So if you write based on the second row, okay, this is 2 only. Anyway, you know that this is 2. So if you write based on the second row, then you will say this is 6, and then you will cut down all of this. Then it will be 6 into determinant of minus 3, 5, and 5 minus 7. Can you tell me the sign of this cofactor? This will be second row and first column. That's why it is minus, right? And then you have plus 0, it does not matter, plus 0 or something will be there, and then minus, plus, then again minus. So minus 4, if you want, you can write like this, minus 4 into this will be 6015. 6015. Okay. Similarly, you can write with first column, first row, second column, second row, any column you can write. Okay. So why it is called cofactor? Okay, I mean, you can write along with any row, any column. If you want first row, first column, you can do it. Can you tell me why it is called cofactor? I mean, I'm not sure if it is official or if it is, like mathematical, but intuitively, like we can argue about it. Like why it is called cofactor. Cofactor means some factor that is with you, that is your companion. Okay. So if there is a determinant A11, A12, A13, A21, A22, A23, A31, A32, A33, if there is determinant something like this, then you will say that if you expand this determinant, it will be A11 into multiple of A11 will be the cofactor of A11. And what is the cofactor of A11? It will be some factor that is coming along with A11, which is A22 into A33 minus A23 into A32. So this is the cofactor. Cofactor means some term which is coming as a factor of this. I mean, which is the factor which is with A11, like that. I mean, maybe this is the argument that we can make. So as I said, I'm not sure if this is some mathematical, but yeah, intuitively it seems like that cofactor of A11 is some factor which is coming along with A11. Okay, in the formula. And then similarly for A22, there will be a, like it is minus A22, there will be cofactor, and then plus A33, sorry, A12, and then A13. There will be a cofactor. Okay. If you are expanding along the first row, you can expand along any row. Okay. You can expand along the second row, second column, like this. Yeah. So if I plus j, so this is I, and indexing, it's not a C programming or it's not a data structure or algorithm. So indexing here always start with 1. This is first row, second row, third row. First row, second row, third row. And then if I plus j is even, then sign is positive. Okay. Otherwise, the sign is negative. That's what we have already written, I think. I've written it. Somewhere I've written it, okay? Okay. Now let's move to some interesting part. Can you tell me, Aij is a cofactors of Aij, the value of determinant, this is determinant, generally we call it determinant, that is given by, what is the answer? If you are it means you are expanding with the first row, then I think this should not be the answer, because A31 is not a cofactor of A11. So this is not the answer. This is also not the answer. This is a mismatch. You want the same cofactors, right? A21, it should be A21, but this is not one. Okay, D is the correct answer, right? Okay. I hope everyone got it. Let's move to this question. They're saying that if we replace the element A11 to 9, then the C11 changes or not? Where it should be minus? Okay, no, Nikhil, cofactor itself has the minus. So A21 will itself be having minus of that determinant, minus of the determinant. Cofactor is not apart from the minus. In the whole thing is cofactor, which is A21. Okay, sign is within the cofactors. So this will be minus of this is 21. So A22, A23, A32, A33. Okay. I think I should be making one of the option. In that option, I should be putting that minus here. So suppose that one of the option is that where we have the minus, then still the D is the correct answer, not that option. Okay. Let's suppose if I have this as one of the option, and here if I remove this plus, okay, assume that this is minus, then C is not the correct answer, D is the correct answer. Okay. And without the minus, actually, this is called minor. Without the minus, without the symbol, okay, so without sign, we call it minor. With sign, we call it cofactor, which means minus 1 power I plus j, and then there will be some determinant. This whole thing is called cofactor. These are just terms, okay? And then this thing is called minor. Yes, sign should be with minus. Okay. Now they're saying that if you replace this A11 with 9, they're saying if you replace this with 9, then C11 changes. Can you tell me what is C11? C11 will be, if you calculate C11, it will be 1001 and then minus or plus, I think plus. So C11 is this. If you make this 9, then C11 is changing or not? So answer is false, right? C11 does not change. Answer is false. Okay. Now they are saying Cij does not depend on Aij. Is this true or false? If we are calculating Cij, let's suppose there is Aij, then cofactor of Aij is Cij basically, then it does not depend on Aij. That is true because that depends everything else on the, I mean, that depends on many things which is not Aij basically. So that is true. What else it does not depend on? Does it depend on, maybe let's suppose this row is I, does it depend on Aik? No, right? Does it depend on this row? Any element on this row does not depend. Any element on this column, it does not depend. Not only on this particular element, it does not depend on any element on this row, any element on this column. Okay. So in both of these given matrices, C11, C12, and C13 are same. They're saying the two matrices are given. You need to calculate C11, which is a cofactor of 1, 1, and 1, 2, 1, 3. You need to calculate here C11, C12, C13. You need to calculate this. And they're saying in both of the matrices, this is same. C11, calculate this. It will be 5, 6, 8, 9. Here also 5, 6, 8, 9, right? I think, yeah, that is true basically. Do you all agree? I think this should be true. Yeah, bottom two rows are same. So this like C11 is basically cofactor of this. Cofactor of this does not depend on this row. That's why if you're changing this row, does not matter. Cofactor of this does not depend on this row. If you're changing this row, does not matter. Cofactor of this does not depend on this row. That's why does not matter. Okay. So yeah, that is true. Now this is extremely interesting. So let's go to this question. Now they're saying let Cij be the cofactor of Aij. Okay. What would be the corresponding matrices for the given determinant? They have given some determinants. It's not A, B, C, D. I mean, these are the 4 questions I have. Maybe let's just talk about the one of them. Okay. For now, let's talk about one of them. They are saying that what will be the corresponding matrix? They have given some determinant. They are asking a reverse question. Okay, they are not given a matrix. They are not asking for the determinant. They are saying the determinant is given to you, and then calculate the matrix. I mean, what could have been the matrix corresponding to this? So let me just try it. See, they are saying A22 into C11. C11 is what? C11 is cofactor of Aij, which I mean, Cij is a cofactor of Aij. C11 is this thing, right? This thing. So it means that I must be having, maybe I must be having, let me write like this, A21, A22, A23, A31, A32, A33, and then on top of the row, maybe I am having this A22, A23, and A21. Why? Because if you calculate determinant of this, then it will be C11. If you A22 into C11, if you calculate determinant of this, it will be A22 into C11, A23 into this C12, because this thing, I mean, these two rows are same. So that is why here also, here whatever I have, right, this is just C12. You all agree? Here A21 into C13, because these two rows are same. So that's why these C's are same. Because this C11, which means the cofactor of this depends on these two rows only, right? I mean, in fact, this depends on these four elements, but in general, I can say these two rows only. Cofactor of this depends on these two rows only. Cofactor of this depends on these two rows only. So I keep these two rows as same, and I just replace the first row with some other elements, maybe A22, A23, A21, something like that. And then if I calculate the determinant of this, then it will be the same. Do you all agree? Okay. See, let's go this way. Let's suppose I have this matrix. Can you calculate the determinant of this? This will be A22 into this thing. And what is this thing? This thing is just same like this, which is C11. Right? Similarly, A23 into this thing, which is A21, A23, and A31, A33. Right? So A23 into this thing, and this thing is just a cofactor of this C12. I mean, with minus I agree, but the whole thing is just C12. So basically, if you go from here to here, then you will be getting this determinant. But they have asked in the reverse way. They have said like the determinant is given, and then can you draw that matrix? Then I think we can draw. If we know that, okay, this is these are the cofactors that have been used of the first row. If the cofactors have been used for the first row, then if I do not want to change this cofactor, then I will be just keeping the second and third row same, and I will be just replacing the first row. If the cofactors of first row are being used, I will just replace the first row. Okay. Now let's move to the next question. So next is the second one. Yubra is saying A22 के corresponding सही नहीं है, A13 पर A23 होना चाहिए. A13 where you want? Here you want A23? Here, like in the original matrix? Veer is saying A22 instead of A11. Okay, let's go one by one. Yuvraj, can you quickly point out what do you want? This is the original matrix. Let's say this is B. Let's say this is okay. This yellow. Top right corner में A. You are saying A22 के corresponding सही नहीं है. A13 पर A23 होना चाहिए. Here you want A23 in this place. Why you want A23? So this is A21. If you just expand this, oh no, these indexes. Let's not worry about these indexes. This this matrix is given to us. Okay, here I have some elements A, B, C, D. Let's just treat them A, B, C, D or something like that. I'm just saying that if you expand these I'm not writing these as indexes. Let's just call them B11, B12, B13. Okay, so these are the B's. These are not A's basically. Okay, so these indexes does not matter. I hope I hope I have not confused you. But yeah, these indexes does not matter. Okay. Okay. Now, let's talk about this question. For the second determinant, can you write the corresponding matrix? See, I have used 1, 2. I have used the second column cofactors, right? 1, 2, 2, 2, and 3, 2. So you can change the second column, but keep everything as else same, which means A11, A21, A31, A13, A23, and A33. And what will be the second column? See, why I'm not changing everything else? Because I want C12. See, if I'm writing second column should be A22, A23, A21. If you expand this, then it will be A22 into some quantity. That quantity is same as cofactor of this. That's why I was able to write C12 here. Right? Because cofactor of this will be A21 into 23 and whatever, right? 23 into 31, like minus of that will be added. So basically, you are able to write C12 because these two columns are not changed. That is why you are able to write C12. Similarly, C22, because For this, if you expand, then this is the cofactor of this, whatever is this. Okay, the cofactor of this is same as C23. So A23 into cofactor of A23. Here, cofactor of A23 same as cofactor of this element, because these two columns are unchanged. Okay. Similarly, cofactor of this and cofactor of this are same. So A21 into cofactor of this particular element, whatever is this, is actually C32, because Cij is a cofactor of Aij. So ideally it should be A21 into cofactor of A21. I mean, based on this matrix, but cofactor of A21 is same as cofactor of this particular element, because these two columns are unchanged. I hope I'm able to convince what I'm saying. See, just see that which particular row or column has been used. Okay, so here you are using A22, A23, and A21. Sorry, you are using C12, C22, and C32, which means you are using this column. So just keep everything else same. You can change this column, and this column should be changed by these coefficients. Okay, and then you can get the matrix. Now it is saying A22, if you expand using this A22 into cofactor of this particular element, whatever it is, A22 or whatever it is, then A22 into cofactor of this is same as cofactor of A12 here, which is C12. Okay. Okay. If that is okay, then can you just tell me what should be the answer for this particular matrix? Maybe I should be having A, B, C, D. Should I have A, B, C, D options? Or okay, let's just do one thing. Just try doing it, and then I will do it. Just write it quickly. Yes, Ekta is saying last two columns should be same. So this is C11, C12, and C13. C11, C12, C13. No, rows should be same, right? Or columns. I think rows. C11, C12, C13. I think rows should be same. So it is A21, A22, A23. Okay. A31, A32, A33. And in place of the first row, you can write these coefficients, which is A21, A22, A23. Okay. Now, what about the last one? I think you can do it easily. Whatever it is, okay, you can do it. Maybe let me do it. Probably this is for the third one. For the fourth one, you can write C11, C12, C13. Okay. In this first row, you should be writing A31, A32, A33, and then you can write other rows as it is: A21, A22, A23, and A31, A32, A33. Okay. Okay. Now, can you tell me the determinant of this matrix? Since two rows are same, I think, right? Two rows are same. You can say determinant of this is 0. What about determinant of this? Maybe determinant of this. This is also 0. What about determinant of this? This is some random, like I think you do not know, maybe, right? A22, right? I think this is some random permutation that we have used, maybe. So this is actually not 0. I mean, in general, it is not 0, right? And what about determinant of this? I think this is also some random thing we have done, right? I mean, we have copied this here, we have copied this here, maybe like some random things. Anyway, so determinants, I mean, like for these two are 0, otherwise not 0. Okay. Let's go to this. Now they're saying that given this, they might have changed something, or the question is same. I'm not sure. So they're saying that which of the following equals to 0? Which of the following determinants are actually 0? Let me check if I think there is some change. Can you do this? This is ABCD basically. Okay. This is, let's take it as MSQ and tell me what are the correct answers. What you got? This is 821, this is 822, 823. A is this, B is, let me try, B is saying that we have C12, we need to replace C12, C22, C32. So B should be maybe A11, A21, A31. Okay. You got A and D. Okay. Many people got A, C, D also. Let me check. Okay. This is C, where you should be getting this C11, C12, C13. I think I should replace the first row only. And here you should be writing A22, A21, A23. Okay. And the D, which is the last option. The last option, I do have something like this. It is D. And here I should be writing, I should be replacing C11, C12, C13, first row only. And here I should be writing A31, A32, A33. Okay. I think this is 0. Okay. A11, A21, A31. This is 0. A22. Okay. This is some random, I think. Okay. This is not 0 probably. A31, A32, A33. Yeah, this is 0. ABD should be the answer. Okay. So ABD is the answer. Anyway, like you can solve it. I mean, this is the potential question that they may ask. I'm sure that if they ask this question, then many people, I mean, many students might not be able to do it. Okay. Yeah, Yuvraj, don't worry. Like either they will ask this, or they will definitely ask something that that we either have taught, or we must have given some intuition or something. So most probably, like whatever we are covering should be sufficient. Either they will ask this kind of thing, or I mean, they can ask anything. Does not matter. But we should be ready for anything. It's be a valid combination. What do you mean by valid combination? A11 is be a valid combination. Valid combination means I'm not getting this term C12, C2. Oh, oh, nice, nice, nice. Actually, B is not the correct answer. Yeah, sorry. B is not the correct answer. Because in the B, you are not sure, first of all, like what to replace even, right? I mean, C12, C22, and C32. Okay, they are saying about the diagonal. So for this, you should not be changing this, right? You should not be changing this. This should be intact if you want to if you want to write like this. And for this C22 to write, you cannot change this element, and you cannot change sorry, you cannot change this element and this element. And anyway, like this is, yeah, this is right. So B is not even the correct answer, because you cannot even write I mean, B is not a straightforward thing that you can write. You cannot even write like this. C12, C22. Okay, sorry. I thought this is a diagonal. Okay, sorry. This is, I think this is correct, right? Okay, this is correct. You made me confused only. This is C12, C22, C32. You want C12, right? C12, C22, C32. Sahi hai. Yeah, that is correct. Okay. So that is correct. Like, I mean, don't get confused with this. This symbol could be anything. This will be replaced. This will be replaced here. This symbol could be anything. These things could be anything. You just focus on these cofactors. ठीक है. So B is the answer. Okay. Let's solve this. Cofactors can be of same row, same column. No, see, these cofactors, you want C12, C22, and C32 same, which means you can replace this second column to anything. If you replace the second column to anything, does not matter. The final answer, like C12 of that, like C12 is basically the cofactor of this particular element. Cofactor of this particular element is C12 here, and that cofactor is getting multiplied by A11. It does not matter column or row. These things does not matter. It basically says that you can replace the second column by A11, A21, and A31. And then if you expand this, then you will be getting the same determinant, which is A11 into, like if you expand along this column, that will be A11 into A21, like A11 into some cofactor, which is same as the cofactor of this A12. Because here also you are getting these four terms, here also you are getting these four terms, which are same. So basically here A11 into cofactor of A12 is also working. Okay. So it is row or column does not matter. If you are able to solve for A, B, A, C or D, then you should be able to solve for B also, because row or column does not matter. Let's solve this. Determine the value. Upon is saying if there are C11, C22, C33, yeah, then we cannot say anything. Okay. Okay. A11 into A12, A21 into A22, A31 into A32 for the matrix A, where Aij is the cofactor of Aij. Can you tell me? See, one way is that you just calculate all the cofactors of these things and then you do all of this, but we know the smart way, right? And this is A12, basically first row, they are calling out A12, A2, so they are changing these three to something else, which is basically they are changing these three to A11, A21, A31. Okay? Yeah. And which means this is same as this column. These two columns are same, that is why it is 0. Okay, I hope everyone is able to do it. Yeah, A is the correct answer. Okay. I don't know about them, like I don't know about the gate, but we will ask in the test series for sure. I mean, in the current linear algebra test that I submitted, in that okay, I won't reveal, but I do not have this. Okay, but later in the mock test or something, we can have. Let's solve this. If elements of a row or column are multiplied with the cofactor of any other row or column, then their sum is 0, which means they are saying that if you are multiplying a row with the cofactors of other row, which means if you are multiplying a row that is basically second row, A21, A22, A23, with the cofactors of maybe the first row or the second row or the third row or some other row, okay, then it should be 0. That's what they're saying. Is this always true? Just think about it. See, if you're multiplying this with C11, C12, and C13, which means you can replace here, here, and here. Everything else is same. A31, A32, A33. So they're saying if you're multiplying this, these cofactors, these three cofactors with maybe this row does not matter, which means you can change the elements of this but these three rows with whom, with whatever you are multiplying with whatever row you are multiplying with. Maybe you can multiply with the second row, maybe you can multiply with the third row, maybe the fourth row if there are four rows, like that. So let's just multiply. They are saying the second row, which means you are copying this. That's all. If you are copying this, then cofactor will be 0. Similarly, let's suppose you multiply with the third row, then also cofactor will be 0. Then you are copying this. Basically, if you multiply any particular row, this particular row, with the cofactor of others, maybe cofactor of this, maybe cofactor of this, okay, the first row, maybe cofactor of the third row, then this is 0. So basically, let's suppose you have a matrix. Let me have a column. Let's suppose you calculate the cofactors of these columns, maybe 1, 2, 3, 4. Okay, and let's say that these are the some values A, B, C, D, maybe P, Q, R, S, X, Y, Z, W. Now, if you multiply the cofactors of this particular column with this, then it means what? You're copying this particular column. Why? Because if you copy this, it will be A, B, C, D, And then if you expand this, it will be a into cofactor of this, which is basically C11, okay, plus b into cofactor of this, which is C21, like that. Which means if you are multiplying the cofactors of this column with the cofactor of other column, then you are basically copying the columns. Okay, maybe let me explain more. See, suppose you do not know that what is there, but suppose that cofactor of this is C11, cofactor of this is C12, cofactor of this C13, cofactor of this C14. Sorry, this is 1 1 4 2 1 2 3 1 and then 3 4 1. Okay, this should be 4 1 2 1 3 1 and 4 1. So what I'm saying, suppose you do not know whatever you are multiplying with, but this was the initial matrix. Here I'm yet to fill this, but suppose I multiply this C11 with some number, maybe let's have some number which is alpha. Maybe I multiply this C21 with beta, and then this C31 with gamma, and or maybe W or omega C41, something like that. Then it means this final is a determinant of what? Determinant of a quantity where I have alpha, beta, gamma, omega. Because if you expand along this column, you will be getting the same thing. So whatever you are multiplying, basically that get copied here. So if you are multiplying with, suppose instead of alpha, beta, gamma or these things, if you are multiplying with A, B, C, D, if you are multiplying with some column, then that column will get copied. Then finally the determinant will be 0. If I'm multiplying ABCD, then ABCD will be here. Multiplying PQRS, then PQRS will be here. Okay. So if you multiply any row with some other cofactors, you will get 0. But suppose you multiply a row or column with its own cofactor, which means that let's have a matrix. Okay, A, B, C, maybe P, Q, R, X, Y, Z. If you multiply in this matrix, if you multiply A with a cofactor of its own thing, if you multiply P with a cofactor of its own thing, if you multiply X with a cofactor of this own thing, then what you will get? You will get a determinant of this A. You will get a determinant of this A. If you multiply, let's suppose this C11, C12, C13, if you multiply these, the cofactor of A, cofactor of P, cofactor of X with some other row, instead of this own row, you multiply with some other row, maybe this row. And then what will the answer? This is 0. Okay. Suppose you multiply this C11, C12, C13 with let's suppose that you multiply with maybe some column, maybe P, Q, R. Then what does this mean? Can you write this in the matrix form? I think you will be writing PQR. You will be replacing the PQR, and then this is as it is, which is BQ by CRZ. Then you cannot say anything. Okay, this is something like you cannot say. You do not know basically. Okay, depends on the values. You cannot say. Which means if you are multiplying a row, a cofactor of row with its own row, you will get the determinant. If you are multiplying a row which is BQ by or any other row, maybe APX or something. Okay, you're multiplying a row with some other cofactors, other cofactor of some other rows, then you will be getting 0. If you're multiplying a row which is or a column or something like that, you're multiplying with some random thing. Okay, cofactor of this, cofactor of this, then it could be anything. Okay. But if you're multiplying a row with some other row, other cofactors of other row, it will be 0. A column with cofactor of other column, it will be 0, because then you're copying basically. You're copying 2 rows or 2 columns. Okay. Now let's just do this. Can you find this product? When you want to multiply, these are some cofactors that you have. These are scalars only. Okay, these are scalars. Okay. So you are basically multiplying this A11 with this. Can you tell me what is this? A11 with its own cofactor, A12 with its own cofactor, A13 with its own cofactor. I think it will be determinant. Okay. Finally, the first entry is getting a determinant. There are remaining 8 entries I need to fill. I know. So let's go through the second entry. So it will be, you are multiplying the first row with the second column, which means you are multiplying this A11 with the cofactors of the second row. These are the cofactors of second row, right? See, this this is basically generally A21, A22, A23. And what are the cofactors of the second row? These are C21, C22, C23. So C21, see, I have written this in the column. Don't get confused. I have written these cofactors in the column. Okay. So if you multiply this row with these cofactors, can you tell me what are these cofactors? These cofactors are the cofactors of second row. You are multiplying the cofactors of second row with the first row, which means you will be getting 0. Is this okay to everyone? Karthik, is this fine to you? Arnav, please let me know. Okay. So, see, just observe here. This is a row that you have. You are multiplying with this quantity. What is this quantity? What is this quantity? This is a cofactor of the second row, right? You are multiplying the first row with the cofactor of second row. That is why you are getting 0. Nikhil, is this fine? Or some other people, maybe Akash, Anirudh, Anuj? Okay, ठीक है. Okay, Nikhil is saying it's confusing. See, are you people convinced till this point that you multiply a row with its own cofactor, you get determinant. You multiply a row with some other row cofactor, then you will get a 0, right? Because you are copying that thing. I mean, we have been doing this in this exercise. Okay. Till this point, is anything fine? Everything fine? So you know that if you multiply cofactors with some rows or column, then how to write the corresponding matrix, that you know, right? ठीक है. Okay, that's okay. Like it's the first time, then it might take some time, but let's go step by step. So given a some expression, you can write the corresponding matrix, right? At least you can write the corresponding matrix. So if that is C11, C12, C13, then you know that there is something you have to do with the first row. You need to replace the first row. Okay. And to what you need to replace, it depends on those coefficients. If this is second row, you can replace the first row with the second row. If this is third row, you can replace the second row, first row with the third row. Now, suppose if this is second row, it means what? In the place of first row, you're replacing what? These quantities. If this is second row, you will write the second row. And it means what? The determinant will be 0. So basically, if these coefficients are second row, the determinant will be 0. Similarly, if these coefficients are third row, like just in D, then you are copying the third row here, right? If these coefficients are first row, you're copying the first row here. If this is maybe the second row, you're copying the second row here or whatever. Okay. So I mean, if you're multiplying a cofactors of first row, which is this, it means you're replacing the first row with what? With these coefficients, which means if you're multiplying the coefficient of first row with these numbers, you are replacing the first row with these numbers. So basically, if you multiply any row with any row cofactor with some other row, you are basically copying those two rows, and the final determinant will be 0. Okay. So if you just see here, you multiply this first row with this quantity so happens to be a cofactor of the second row. That's why it is 0. You multiply this first row with this quantity also happen to be the cofactor of the third row, right? This is the third row, which is A31, A32, A33. This is C31, C32, C33. That's why this is also 0. Similarly, if you multiply the second row with this is the cofactors. Let me write cofactors of first row. This is cofactors of second row. These are cofactors of third row. If you multiply the second row with the cofactors of this is first row, then what you will get? You will get 0, right? If you multiply the second row with the cofactors of first row, you will get 0. You multiply the second row with the cofactors of the second row, you will get Can anyone tell me? Determinant. If you multiply the second row with the cofactors of the third row, you will get 0. If you multiply the third row with the cofactors of first row, you will get 0. Third row cofactors of second row, you will get 0. Third row with its own cofactor, you will get determinant. Right? This is a matrix, okay? I mean, that won't be cube or something. It is a matrix. It is not a determinant. So this is a matrix. Okay. You can take a determinant of a common. This will be just one time common. Okay. Okay. So basically, here we got determinant of a 0, 0, 0, determinant of a 0, 0, 0, determinant of a. Okay. Now, can you do the same thing here? So these are the cofactors of first row. These are the cofactors of second row. These are the cofactors of third row. Now tell me. This is okay. Instead of saying like this, I mean, that's okay. I mean, that's not a problem. But instead of saying like this, I want to say in some other way. I mean, that is okay. Whatever I have written, that was correct. But I want to write in some other way, maybe. Okay. Maybe let me say that instead of writing like this, tell me this row, because I'm multiplying this row, right? So this row is a cofactor of what? C11, C21, C31, right? Cofactor of this row is a cofactor of this particular row is a cofactor of first column. Why it is so hard to visualize? This is C11, C11, C21, C31. This column cofactor will be like this, right? This row is a cofactor of second column. This is a cofactor of third column. Okay. Now, if you're multiplying cofactor of first column with its own column, okay, with its own column, what you will get? You will get a determinant. If you multiply cofactors of first column with second column, what you will get? You will get 0. Cofactors of first column with the third column, you will get 0. Again 0, determinant of a 0, 0, 0. Cofactors of third column multiplied with cofactor by its own column, you will get determinant. Basically, these two matrices are same only. Instead of multiplying A into B, I am also checking whether B into A is also getting the same thing. Like I was fortunate to get the same thing. Otherwise, it is not in general. I mean, A into B could be anything, and B into A could be anything. If this matrix is A, this is B, then A into B and B into A could be anything in general. But here, I was just fortunate to get the same thing. Okay, everyone got it? So, can you tell me now the inverse of A? See, using this, you can say that this is nothing but, okay, this is nothing but, you can take a determinant of a common 1, 0, 0, 0, 1, 0, 0, 0, 1. So basically, you can say that A into, let's suppose this is C or something like that, A into this B is actually determinant of A into identity. Right? So I can say that A into B I got as determinant of A into identity, right? Yeah. No, this is not determinant cube. This is a matrix. Just because we are having a determinant chapter does not mean that everywhere you need to think about determinant. These are the matrix multiplications, right? Okay. So it was A into B is determinant of A into identity. That's what we got. And then similarly, B into A also we got as determinant of A into identity. Okay. Now inverse is defined in some way where you say that A into something is identity or something into A is also identity, then it is called inverse. So if I just put this determinant of A, maybe if I just put this determinant of A on the left side, if I just say that this is maybe, let me just try doing this, because since this is scalar, okay, you can multiply in a, you can multiply in b, whatever. So let me just say in this way, let's say this is a into 1 upon determinant of a into b. Okay, similarly here also, instead of writing like this, let me write like this. This is the thing. Now can you tell me the inverse? Inverse is something you multiply that thing, you get the identity either on the left or on the right. So now from this observation, can you tell me the inverse of a? Karthik is saying when we will solve, it will be that determinant of a into. No, you are not finding the determinant anywhere. These are just a matrices. Get over it. Okay. Determinant is gone. Okay. These are the matrices that you have. We are not finding the determinant any place. Okay. So can you tell me the inverse of a? Can we just say the inverse of it is this? Isn't it? Because inverse is something, if you multiply that matrix, then you get the identity either on the left side or on the right side, on both sides, not just on the left or not just on the right. So this is a matrix where I'm multiplying on the left or right, I'm getting the identity. That means I can say that A inverse, I can say from here that A inverse is B upon determinant of A. And what is that B? I think that B I have assumed to be this cofactor matrix. Okay. So if someone asks you that what is the inverse of A, then you will say that this matrix, which you have assumed to be B, this matrix into divided by determinant of A. So you will say the inverse of A will be this matrix divided by or multiplied by 1 upon determinant of A. So that's how we get the inverse. Right? So if someone asks you what is the inverse of A, you will say that A inverse, you do not need to drive again and again, but you can say A inverse is that matrix, whatever you had, into determinant of A. Okay. And what is this matrix? You can say that this matrix is basically C11, C12. I mean, if you write in this way, C11, C12, C13, C21, C22, C23, and C31, C32, C33. If you write in this way, then this is a cofactor matrix. And if you take the transpose of this cofactor matrix, this is the matrix that you are getting. Okay, this is a general C11, C12, C13 like this. So this is a cofactor matrix. A cofactor matrix, I mean this thing. Okay, so this is a cofactor matrix, and if you take the transpose of that thing, you get this. That is called adjoint. Yes, that is called adjoint. Okay, so let me denote it by C. Okay, I should have denoted with the C instead of B, but that's okay. So C is your cofactor matrix, and there is one more notation. I know there is too much of overwhelming notations are there, but yeah, that's called adjoint of A. Adjoint of A, which is just a C transpose. Okay. So finally, you have A inverse as adjoint of A. This is called adjoint of A. This is called adjoint of A, and adjoint of A, which is this, divided by determinant of A. This is called adjoint of A, which is also the C transpose, and where C is your just a normal matrix C11, C12, C13, C21, C22, C23, C31, C32, C33. Okay. Is this okay to everyone? Let me know if there is any confusion. Okay. So basically it is easy. It just took time to explain me, but it is actually easy. You take a matrix of cofactors, okay, or maybe you take an adjoint of it. You just multiply by the A, and you got to know that, okay, if you multiply by the A, if you do this kind of multiplications, then you are getting this matrix. Okay, and that's how we can find out the inverse. So you just discovered that, okay, if you take a matrix, you multiply a transpose of cofactor to that, then you get something which is like this. You either multiply on the left or multiply on the right, you will get this. To just get on this conclusion, we had to explain all of this. Okay, so that you get to understand that how this inverse is coming out. Okay. So this, if you want to calculate this adjoint, this is a transpose of the cofactor matrix. And how you calculate the cofactor matrix? To calculate the cofactor matrix, you will be taking the determinant of this based on the sign. So this is how we calculate the adjoint. And inverse, A inverse will be 1 upon, right? That's how you calculate the inverse. Okay. Now you can find the inverse of this. As in homework, you do it. Okay. I have the answer on the next slide. First, you need to find the determinant, then you need to find the adjoint. For that, you need to find the cofactors. You take the transpose of that, you will be getting the adjoint, and then you can find the inverse by this formula. Okay. Just try it out because it is necessary to have some practice of the inverse also. So try out on your own because it is just a calculation. Okay, but you have to do it. Yeah, this is a lengthy calculation, but there is no other way. Okay. For 2 by 2 matrix, basically, if you find out, then the determinant is this, and the cofactors are actually very easy. For cofactor of A, just D. Cofactor of B, can you tell me cofactor of B will be? Cofactor of B will be? Tell me quickly. Minus C, yes. And cofactor, this is plus minus. Cofactor of C will be B. Cofactor of D will be minus A. You take the transpose of that and you get the adjoint, which means you take the transpose of this C, then you get the adjoint, which is basically D minus C and then B minus A. B minus A or minus B? For C, the cofactor is plus minus. Okay, this is second row, first column. This should be minus. Okay. Second row, first column. This should be minus plus. Okay, nice. So, okay. So here it is minus. It should be plus. Okay. Then you take the transpose of that. You will be getting this. So yeah. So basically, there's a shortcut. In shortcut also you can remember, which is that you just swap these two. You swap these two. Okay, you do not swap these two. You swap these two and you put minus here. Then you get the inverse of this. And AD minus BC is just a determinant. If you want, you can calculate. Otherwise, you can just remember like this. You swap the principal diagonal. This is called principal diagonal. And you swap the principal diagonal, change the sign of this other diagonal, and then you will be getting for 2 by 2 at least. There's a shortcut. For 3 by 3 and these things, there is no shortcut. Okay. Okay. So let's meet tomorrow and then we will be doing some more calculations tomorrow.